So depending upon what you are given, you have three different options, or really two different options to work with that you can backtrack to and convert them into what is called standard form. Example 1, if you are given a point, you have a point, and you have slope, which, by the way, slope is traditionally abbreviated as M, okay? If you are given a point and slope, solving for a standard form equation begins with you utilizing point slope form and then backtracking. So let me give you a slope of 3 and points of 5 and 10. A slope of 3 and points of 5 and 10. If you are given this data and you are told, find an equation in standard form of a line containing the point 5, 10 and having a slope of 3, step 1 is going to be to quickly sketch out point slope form. Y minus y1, yep, is equal to m x minus. Okay, very good. So plugging in the information, the y value gets plugged in for y1. The m value gets plugged in where the m went. And the x value goes where x1 was. Okay? Now we need to gradually convert this to standard form. So we'll start y minus 10 equals 3x minus 15. Remember, standard form is something x added to something y equaling c, and x is preferably positive. I say preferably because technically if x is negative and everything else is also correct, you can still have a correct equation, but by definition, x needs to stay positive.
I have a question.
Yep.
When you're doing y minus 10, can you just bring it down out of the parentheses, or do you have to multiply it by 1?
Well, you're...
Like, do you distribute 1 or no?
Nah. Okay. You're, by definition, you're doing it.
Okay.
Yep. So I'm going to bring my y's to the right because I want to keep that 3x positive. Bring my numbers to the left, giving me 5 is equal to 3x minus y. Or writing it right to left, 3x minus y equals 5. Either of these is okay because the x indeed is positive. Okay? Either of those is okay. You're given a pair of points and a slope, and you have just taken a line or made a line out of the points and the slope in point slope form and then converted it to standard form right there. They're always going to say, give me an equation in standard form. Now, another way to check yourself is to take standard form M is the opposite of A over B. And that's in the slope is opposite of A over B. And A is the 3. Thank you. B is negative 1. The opposite of that is 3. Is that what we said slope was? then you know you're correct, or at least you have a pretty good indicator that you're correct. How about another one just like it? The line, I'll flip actually.
Wait, so what do you need for your answer? Do you need to put 3x minus y equals 5, or do you have to have?
Either of these.
Okay.
Either of those is fine. I just always like to write it x, y equals blah.
Okay.
Okay. We went from point slope form, stopped at standard form, checked our slope, taking that m value and verifying that the m value we were given is the same thing as the opposite of a over b in standard form. Okay, here's a couple more. Find an equation in standard form for a line that goes through this point and has a slope of 2. Step 1, write out your y minus y1 thing. Filling in your y1, your m, and your x1 values. y1, m, x1 values. So right now we've used point slope form, plugging in our data. Take point slope form and maneuver it so that you have standard form. That x is positive, so I'm going to move my y to the right. Nine equals 2x minus y. The other way would be 2x minus y equals 9. M is the opposite of whatever a over b is, so let's check that. 2 over negative 1, opposite is 2. Are we good?
No.
Hallelujah. We can check it. Okay. One final example for example 1. It goes through points -1, 3, and has no slope, aka it is a cliff. Okay? No slope. Y minus y1 is equal to m x minus x1. This one's a little bit tricky, honestly. Whoops.
Wait, if there's no slope,
Yeah, bear with me here a second. So what does 1 do? Y minus 3 equals, I don't know what to do here, x minus x1, -1. Well, truth be told, there is no y value.
no what?
No y value. There's no, like, okay, so if there's no slope, when you go back to standard form, doing it this way just seems a little bit weird, I guess is what I'm trying to tell you. Doing it this way when there's no slope given is kind of weird. Okay? Thinking this way is kind of weird. Well, what do I do with this? Is this a 0? Is it a 1? What do I do? So I am going to challenge you, if you are given this piece of information, I want you to recognize something. No slope, and this is the points you're given, so over -1, up 3. That means the line would be here, right? wouldn't it be fair to just say that's all you have? X is -1. But that's not standard form. Okay. Standard form then would be x plus 0y is -1.
Oh, okay.
Right. That's why when you are given a no slope scenario, no slope, x is always this value. There it is. This is standard form. It just doesn't show the 0y. Okay? So don't really think about plugging it in and trying to fool with it that way, because it really is just a pain in the rump. Just recognize, okay, then x is always -1 if there's no slope. X is always -1 if there's no slope.
So if it was like 3 and 5x would be
If the points were what? Say it again, I'm sorry.
3 and like 5.
3 and
it would just
5.
be
X is
plus
3.
0, y equals 3.
Yep,
Okay.
exactly right. Very good. This one would just be x is 3 because x plus 0y is 3. Very good. All right. The next two examples are super, super easy now that you've seen this. What if, in example 2, you are given 2 points? Well, all you need to do with 2 points is get a slope and then go back to example 1 technique.
Okay.
Here's what I mean. If you are given these 2 points, and per the directions in example 2, it says, find an equation in standard form of a line containing these 2 points. In the previous example, you were already given slope. In this example, you're just going to get it for yourself. You're going to get it by finding the difference in y's over the difference in x's. And I'm going to go 5 minus 4 and -3 minus -6. Be very careful about that. Okay? 5 minus 4, -3 minus a -6, which means you add. 1/3 is your slope. Okay? You now have slope and you have 2 points. All you need to do now is pick a point. Doesn't matter which one. I generally pick the one with smaller numbers. So I am going to pick, my slope is 1/3, and I'm going to pick -3, 5. It really doesn't matter. These are pretty close in numeric value. Y minus y1 is equal to m x minus x1. Notice I flipped that sign. Y minus y1 equals m x minus x1. This is going to be 1/3 x plus 1. Okay, 1/3 of x, 1/3 of 3. X is already positive, so I'm going to move my y to the left. Move my 1 to the right. -6 is equal to 1/3 x minus y. So if you're given 2 points, it just requires that you get your own slope. Okay? It just requires you get your own slope. That's all it requires. To check yourself here, you could take the equation that we just came up with, verify that the opposite of A over B indeed is slope, or oh shoot, I forgot to show you something. I forgot one thing. You know how I told you X is positive? It's also preferable X is an integer. Integer, I cannot write. integer. Right now, X indeed is positive, but this is not a whole integer. To make this, and nowhere in any curriculum is this explained very well. I've just figured it out over the years that the book is always going to give integer answers. We're going to multiply everything by 3 to clear our fraction. Negative 18 equals X minus 3Y. Okay? That is the second piece about X. You've already seen that X is positive, but in the back of the book, this would be the answer, and you would think you're wrong.
So
if you give me this, I would have to convert it for you, because my answer key is going to have all that.
So what is it wrong, or we shouldn't do it?
Well, how about this? This is how you need to do it.
Okay.
X needs to be an integer in standard form. This all applies to standard form. AX plus BY equals C. Okay? The last thing that I have for today, and I promise this is the last bit, is utilizing slope-intercept form. And this one's super easy. Utilizing slope-intercept form. When you are given slope and when you are given the y-intercept, in other words, where the line crosses the y-axis, the up-down axis. So if I tell you that the y-intercept is -4, and the slope is 1/2, it is super easy to get a formula out of this, starting with slope-intercept form. M is slope, B is the y-intercept. Plug in what you got. Y equals 1/2 X plus a -4. We're going to maneuver that around and then clear our fraction. It's going to look like this. 4 equals 1/2 X minus Y. Multiply everything by 2. 8 equals X minus 2Y.
Wait, why is the y integer not y?
Hmm?
Why is the y integer not y?
Why is the y-intercept not y? Because it's the y-intercept. Y-intercept is B.
I know, why is it b and not y?
You're going to have to go back in time and ask the people that created this. Yeah, that when you're solving this form right here is just how it is. Rather than get into the y's and the how's. And if you maneuver stuff around here and you plug that y value in over here, then what you would have is -4 equals 1/2 X plus B. What's B? Well, it's -4. Well, then you're going to have 0 equals 1/2 X, and none of that would jive. It's just like saying, why do you put 2 cups of sugar in to bake a loaf of bread? Well, over the years, bake a cake. Over the years, the recipe to get there, and the folks that figured out how to explain this using variables, this is the proper representation for all of this. Okay?